pulls the plane down? Gravity, yeah. We all know that force, right? Gravity. Because the plane's pretty heavy. But then how can a plane fly if it's got all these forces that, make it want to go down, or forward, or backward? What keeps it up in the air? What sort of force is that?
All right. So what percent?
Any ideas?
Try to get it in the head box.
So how about what's that? Yeah, exactly, lifts, right? So when you have something really heavy and you want to carry it, you have to lift it up, right? So that's any sort of force that pushes you up is called lift. Okay, so now we want to go into specifically what keeps the plane up, because lift is the force, right? And we know that it has something to do with the wings, like you said earlier, right? But then what specifically about the wings makes the plane stay up? So if you see in the middle of your worksheet, you have this diagram of the cross-section of the wing. So that's if you look at the wing from this side. If you look at it straight from the wing, you see that the top is a little more curved, right? So the top and the bottom of the wing are shaped differently, and that actually helps the plane fly because as air, so these arrows are the lines of how the air travels as it goes over and under the wing. So like you can see, the air when it goes over the plane, it gets compressed, right? It gets smushed because of the curve of the wing. So that actually makes the air go faster because there's a lot more of it, so it's pushing itself and it's moving faster. And then the opposite happens on the bottom because there's no curve there, so it can just flow straight across. So it flows slower. And there's something called the Bernoulli principle. It's a really big word, and you'll learn about it later. But right now, we just need to know that Bernoulli principle basically says that when everything else is the same, air that moves faster creates lower pressure. So does anyone know what pressure is? Any ideas? I'm sure you guys have learned about it, right? So it's kind of like force, right? So it's the force that's exerted over a certain area. And you guys have heard about atmospheric pressure, right? Like we all live, and there, as we go where we're living, there's a certain amount of pressure that's pushing down on us, right? That's just from the air in the atmosphere. But we don't really feel it, right? Because we have that same pressure when it's inside our body. So that's kind of the same idea here. Like when there's a lot of air flowing, there's less pressure because the air is moving faster. And then when the air is moving slower, it kind of stays more in place, so there's more air molecules, so they create more pressure because it's pushing, right? So then what happens is, since the air is traveling faster on top, Bernoulli's principle says that the pressure is going to go down, and when it travels slower on the bottom, the pressure goes up because there's more air molecules at one time, right? They're pushing on each other and they're pushing on the plane. So what happens then if the pressure is really, really high on the bottom and it's less so on the top? What happens? Which way does the wing go? Up, right? And that's what keeps the plane up. So it's basically Bernoulli's principle and this difference in pressure. But this is true for an actual plane, right? Where you get an engine and you have a different wing shape. So then what happens in the planes that we're going to build, which are paper airplanes? Can anyone think of a really big difference? Quite a few. Yeah? Yeah, so they have flat wings, right? We don't have that sort of difference in the thickness of the wing. So what we want to do is we want to create that difference by you can make depending on by shaping your wing differently. So you can either fold the wing flaps, and what this does is it actually makes the plane more stable. So like when you're throwing your plane and it starts to wobble, right? If you have wing flaps, what that does is when the air travels across it, it pushes the wing flaps and it actually makes the plane stabilize. So this is something you can try. And then anything else that's different about a paper airplane compared to a real one? Yeah? It's what? It's paper, yeah. So it's a lot lighter, right? And that means that any little difference that you make to the shape is going to affect how it flies a lot more. Yeah, that's very good. What's that? Yeah, it doesn't have a motor. So in a plane you have engines, right, on the wings that push the plane forward constantly. But in this case, what do you have? What's the initial thrust Yeah, just when you throw it, right? So once you let go of it, there's no longer anything pushing on it, and that's why it stops a lot faster than if you had motors on it. Yeah, so those are some of the really big differences. Okay. And then there's a lot of little modifications you can make to your plane to see how it affects the way it flies. We've already talked about wing flaps, which might help stabilize it. And then you can also experiment with turning them different ways to see how that affects the way the plane turns. And also, if you create little flaps that go up, like we've said, it's made of paper, right? So every little change that you make makes a really big difference. So if you make flaps that go up, it'll actually make the plane like stall a little, right? So it goes up. Thank you. So yeah, if you throw it fast enough, if you have these little wing flaps that go up, it might go this way and then it will keep going, which is really cool. So you guys can experiment with that. Also, you can try. I don't know. We have paper clips. I don't know how to use them. I'll find them. We have paper clips that you can put on different parts of your plane to see how that affects it. If you put it more towards the front, it'll make your plane more stable, so it flies faster and it gets to wherever it goes really stably. And if you put it on the back, that pulls down the back of the plane, right? So it might be a little similar to what you just saw, where it flies and then since the back is getting pulled down, it might do a flip or it might just start tumbling. So we have paper clips that I'll find, and you guys can experiment with that. And we have these 4 different designs up here that you can try for your paper airplane. There's the hoop nose scooter, which is this one, and it's really cool because there's this little like ring in the front that helps stabilize the plane. So it makes like when the air flows through, it makes sure the plane stays and flies straight. And there's the classroom cruiser, which is really, really balanced and it's really stable. And it's really easy to make, so you don't have to worry about like hard stuff. But and then there's the Albert Ross, which is really stable as well. It flies a little slower, but it's really, really stable, so you might be able to go farther because of that. And then there's the Sweet Street, which has this really cool like aero-like design. So that also flies pretty fast. So we have paper up here, and you guys can get started. And we'll be holding a competition afterwards to see who can fly the fastest and also the farthest. So yeah, if you have any questions, come to us. We'll help you make these planes, so don't worry. There you go. Here's your paper. Oh, I forgot to use this. And I totally taught you. That's fine. I just realized. I'm sorry. I should have